Hello everyone, good morning. Welcome to Just Get Civil, and we are here for Mission Gate 2021. So, in the series of the lectures, we are entering to the eighth lecture. So, in this lecture series, we have already so first of all we have already done with the we have entered to the water treatment process for the domestic water supply engineering, and we have seen that we have already done up to the primary sedimentation process. This primary sedimentation process, generally, we have seen that yesterday's class that we have given the process of or defined the process of removing the suspended particles having diameter 10 to the power minus 1 to minus 3 mm in water by the plane sedimentation or type 1 settling or discrete settling process, right? Now, today's class will comprises specifically, we will see that today's lecture, first of all, myself Soumyajit Sen, uh, hashtag just get me, and before going to the details of the class, one thing I should mention that if you don't have the till date, you don't have, अगर आपके पास Unacademy learning app ना हो, please go to the Play Store and type Unacademy learning app and install the Unacademy learning app, and then you will go for the GATE and EAC. Generally, you can go for your courses, your preferred courses. Go for plus subscription, and there you will get personalized mentorship, and even you will get the process where you can deal with the we will get the subjects or topics from the plus educators, topmost educators of Unacademy. Go for the subscription button, click the subscription button, and if you are going for the subscription button today, if you put my code SEN10 SEN10, don't forget to put my code SEN10. Don't forget to put my code SEN10. This particular code will give you direct 10% discount today. SEN10. Don't forget to put this code SEN10. And a great news for civil engineering students, aspirants for GATE 2022. You can say it's a new year gift that Unacademy is launching a batch for 28th December for civil engineering GATE 2022. Evolve for GATE 2022. Civil engineering batch A, English and Hindi, starts on 28th December 11:15 a.m. So this is the thing which you have to you actually the 2022 batches aspirant students are waiting for. So don't get late. It's better to start to at this time itself. It's best to start early. Go for the subscription of this class, and while taking the subscription, don't forget to put SEN10 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 as your code SEN10. Okay. And another great news that Unacademy Combat has once again came and combat with that it is a free enrollment. Next combat will be on, already one combat has over. Next combat will be on December 29th, year ending bonanza, 6 p.m. Register now. To unlock, use the code CRACKGATE, CRACKGAT. Use the code CRACKGATE. Win exciting prizes from rank 1 to 3. 3 month subscription or Amazon Gift. 3 months GATE and EAC subscription or equivalent Amazon voucher. Rank 4 to 50, rupees 500 Amazon voucher. That is for this upcoming combat, December 29th, 6 p.m. Free registration, enroll free. To unlock, use the code crack get, CRACKGATE. So that is the thing, and hope we'll together crack the examination. Let's crack it. And to crack this, we are going for the chapter 4, going for treatment of water, continued with coagulation and flocculation process, continuing with coagulation and flocculation process. Now, previously, what we have seen that in a previous chapter, that when we are talking about the plain sedimentation process, generally we are concerned about the sedimentation of suspended particles. Now, apart from suspended particles, two more type of particles present in water. One is colloidal particle, another one is dissolved solid. Though different particles also present in water, एक है colloidal particle, another one is dissolved solid. Now the question is, what will happen with them? As in the plain sedimentation process, I have told you when we have discussed the very basic scheme of water treatment process, that plain sedimentation is concerned about the suspended particles. The colloidal particles are generally taken care of by this coagulation and flocculation process, and the dissolved solids are taken care of by filtration process. Now the point is, what is this coagulation flocculation process? Before going to the details or before going to the written notes, I'm just discussing what is this coagulation flocculation process. What is coagulation and flocculation process? Just try to understand. Well, leave it. First, generally, the colloidal particles, because of their low specific gravity, they won't be able to get settled down in the plain sedimentation process. The colloidal particle of their low specific gravity won't get settled down in the coagulation in the plain sedimentation process. And these colloidal particles are not that easy to handle. They are specifically charged particles. They are specifically a charged particles. What charges they generally they are having? They are having negative charges. Having negative charges. Due to their charges, what they generally do, suppose this is a colloidal particle, negative charges, they form a layer of boundary of पॉजिटिव चार्जेस. ये जो बाउंड्री लेयर बना रहे हैं, नॉर्मली एक बाउंड्री लेयर का काम क्या होता है? नॉर्मली एक बाउंड्री का काम क्या होता है? एक बाउंड्री एक पर्टिकुलर घर को या कुछ जगह को प्रोटेक्ट करता है फ्रॉम द आउटसाइड इन्फ्लुएंस. They will not increase the surface area or floor area, anything like that. This boundary layer, the charge boundary layer, will not increase the mass of the particle. What they will do, they will protect the colloidal particle from outside influence. So they will they will form a boundary layer of charged particles, positively charged particles, as they are having negative charges. These positive charged particles, they form another layer comprises of both positive and negative charges. Both charges will be there. Another layer. The first layer is called as stun layer, and the second layer is called as diffuse layer. अब हो क्या रहा है? अब ये हो रहा है कि ये जो दोनों लेयर है, stern layer and diffuse layer, they both are protecting this colloidal particle from outside influence. They both are protecting this colloidal particle from outside influence. And this is called as electronic bilayer or double layer stability. Electronic bilayer or double layer stability. इलेक्ट्रॉनिक बाइलेयर और डबल लेयर स्टेबिलिटी, ये दो बाउंड्री लेयर क्या कर रहा है, कॉलॉइडल पार्टिकल को बाहर के इन्फ्लुएंस से बचा रहा है, बाहर का इन्फ्लुएंस से बचा रहा है. दे आर एक्चुअली प्रोटेक्टिंग द कॉलॉइडल पार्टिकल फ्रॉम आउटसाइड इन्फ्लुएंस. Now as they are protecting the colloidal particle from outside influence, so eventually what we need to do, अगर हमको colloidal particle को हटाना है पानी से, the first job will be to break this boundary layer of the colloidal particle, and then you need to free the colloidal particle from this boundary. तो उसके बाद ही आप कुछ कर पाओगे. Now इसको फ्री करने में, इसको हटाने में, you need to break this boundary layer. How we will break this boundary layer? To break this boundary layer, certain chemicals will be applied. Certain chemicals will be applied. So to break this boundary layer, certain chemicals will be applied to the system. These chemicals are called as coagulant. These chemicals are called as coagulant. Certain chemicals will be applied as coagulant, and those coagulant will be, what they will do when they're applied in coagulant, as coagulant, these chemicals, they dissociate into ions, cations and anions. Their anions will try to destabilize this diffuse layer positively charged particle. ये जो नेगेटिवली चार्ज एनायंस है, ये डिफ्यूज लेयर का जो पॉजिटिव चार्जेस हैं उसको डिस्टेबलाइज करने का कोशिश करेगा भी. And then and there, as this positive charge particles is getting destabilized, the negative particles will be also get destabilized. जैसे ही ये डिफ्यूज लेयर टूट जाएगा, वैसे ही आपका स्टर्न लेयर that will get destabilized and it will also break. So eventually what is happening is, as you are applying certain chemicals from outside, and they are actually dissociating into ions, positive and negative ions. These anions will destabilize the positively charged particles of diffuse layer, and it is destabilizing the diffuse layer, and also it will destabilize the stern layer. So eventually your colloidal particles will be free, and these colloidal particles will be attached with these cations, positively charged ions, and they will make flock. Small size flocks they will make in the water. And this destabilization of colloidal particle and forming of small flocks, the destabilization of colloidal particle and forming of small flock is called as coagulation. The whole process is called as coagulation. The whole process of destabilization and formation of small flock is called as coagulation or chemical conditioning. Coagulation or chemical conditioning, it will be called as. The point is, as you are applying certain chemicals from outside to carry the process, eventually it is not an unit operation, it will be an unit process. As you are applying, as certain chemicals are used from outside to carry this job, it will be called as chemical this process. Okay, but this unit of process. Now, after this, what will happen? There will be a mixing. Before this mixing, another mixing will be there. That will be for the mixing of coagulants in the water. But now there will be a mixing, and due to this mixing process, what will happen? The Brownian motion between the Brownian motion means here and there motion between the small flocks will get increased. Due to this increase in Brownian motion of the small flocks, lot many small flocks will attach with each other, and they will form a bigger size flock. So this process is called as flocculation. This process is called as flocculation, where two or more than two small flocks will attach with each other and they will form a bigger size flock. This process is called as flocculation. Two or more than two small size flocks will attach with each other and they will form a bigger size flock. It's called as flocculation. Now, after when they attain enough size and mass, these bigger size flocks, when they attain enough size and mass, they will undergo when the flocks will attain enough size and mass, then they will undergo sedimentation process. And this is type 2 settling. क्या है type 2 settling? I will describe later. So when they attain enough size and mass, what will happen? They will undergo sedimentation process, which is nothing but the type 2 settling process. Previously, I have told you that when you are concerned about the domestic water supply engineering process, then two type of settling process we will see. One is type 1 settling, another one is type 2 settling. Type 1 settling or discrete settling in the plain sedimentation process. Type 2 settling, also called as flocculent settling, in this sedimentation along with coagulation flocculation process. So first there is coagulation, then there will be flocculation, and finally there will be sedimentation of these flocculated particles, coagulated and flocculated particles. So in brief, it is a sedimentation aided with coagulation and flocculation. Sedimentation aided with coagulation and flocculation. Okay. Now, each and everything is listed here as a note. Just I'm reading it, or extra some concepts are there that I will explain. The first point is colloidal particle, because of their low specific gravity, will not be able to get settled down in water in the process of plain sedimentation. Colloidal particle because of their low specific gravity will not be able to get settled down in water in the process of plane sedimentation. To remove the colloidal particle from water, we have to go through coagulation and flocculation, which will enhance the settlement of colloidal particle. To remove the colloidal particle from water, we have to go through coagulation and flocculation, which will enhance the settlement of colloidal particle. Good enough. Colloidal particles are generally charged particles and they carry negative charges. Colloidal particles are generally charged particles and they carry negative charges. Due to their negative charges, they will attract positive charges present in water. So we have already discussed this. Due to their negative charges, they will attract positive charges present in water, which will form a boundary in the surroundings of colloidal particle. मैंने आपको बोला ही हूँ इसका पार्टिकल का चार्ज नेगेटिव होने की वजह से first what will do, they will attract certain positive charges present in the water and they will form a boundary of positively charged particle. This positively charged particle will form another layer of charged particle. This positively charged particle will form another layer of charged particle consist of both positive and negative charges. This positively charged particle will form another layer of charged particle consist of both positive and negative charges. And generally they are Stern layer and diffuse layer. So this first layer is called as first layer मतलब यहाँ पे देखिए आप जो पहला लेयर बन रहा है colloidal particle की वजह से which is called as Stern layer which consists only the positively charged particle. और जो second layer बन रहा है इस पॉजिटिवली चार्ज पार्टिकल की वजह से जो आपका नेगेटिवली चार्ज पार्टिकल भी रहेगा और पॉजिटिवली चार्ज पार्टिकल भी रहेगा उसको कहते हैं डिफ्यूज लेयर. डिफ्यूज लेयर. These two double layers of electronic charges will give stability to colloidal particle. These two double layers of electronic charges will give stability to colloidal particle. Stability मतलब उसको रोक के रखेगा भैया कहीं पे मत जाओ उसको और या तो बाहर से कोई उसको कोशिश करेगा हटाने के लिए कुछ करने के लिए उसको प्रोटेक्ट करेगा. That is why this is called as electronic bilayer or electronic double layer stability. As to charge layer or electronic layer is protecting the colloidal particle from the outside disturbances. That is why it is called as electronic double layer or electronic bilayer stability. It is called as electronic double layer or electronic bilayer stability. तो हमको पहला काम क्या है इसको तोड़ना है इस स्टेबिलिटी को तोड़ना है. Now to break down the stability we have to apply certain chemicals from outside. To break down the stability we have to apply certain chemicals from outside. It is called as coagulant. So as I have already told you, as we are applying certain chemicals or we are taking certain chemicals help from outside to break down the colloidal particle, break down this not colloidal particle, the boundary which is surrounding the colloidal particle, then that's why it is called as unit process. It is called as unit process. Previously plane sedimentation was unit operation. ना अगर आपको कोई कहीं पे कोई दुश्मन को मारना है दुश्मन को तोड़ना है दुश्मन को हटाना है कहीं से पहला तो है कि आपको स्ट्रेंथ और वीकनेस एनालिसिस करना पड़ेगा. दुश्मन का क्या स्ट्रेंथ है उसको जानना पड़ेगा. दुश्मन के पास हेवी मिसाइल है और आप सिर्फ एक बंदूक लेके चले गए मारने में तो कुछ फर्क नहीं पड़ेगा. तो यू नीड टू नो व्हाट इज द स्ट्रेंथ ऑफ दिस ऑफ योर एनिमी. तो आपको क्या करना है आपको तोड़ना है. किसको तोड़ना है ये इलेक्ट्रॉनिक डबल लेयर को इलेक्ट्रॉनिक बाई लेयर को तोड़ना है क्योंकि आपको चाहिए कोलॉइडल पार्टिकल फ्री कोलॉइडल पार्टिकल. कोलॉइडल पार्टिकल फ्री हो जाएगा तो आप कुछ भी कर सकते हो. Now before the destabilization of colloidal particle इसको डिस्टेबलाइज करने के लिए वी हैव टू मेजर द स्ट्रेंथ ऑफ द इलेक्ट्रॉनिक लेयर. जो इलेक्ट्रॉनिक लेयर बना हुआ है, दो लेयर, उसका स्ट्रेंथ चाहिए. एंड इट इज डिफाइंड बाय a term zeta potential denoted by xi is defined by a term zeta potential denoted by xi, where xi is equals to 4 pi small q delta by capital D. Xi is equals to 4 pi small q delta by capital D, where capital D is the dielectric constant and delta is the thickness of diffuse layer. Capital D is the dielectric constant and delta is the thickness of diffuse layer. And small q is the charge of shear surface. Small q is the charge of shear surface. Shear surface is nothing but interface between Stern layer and diffuse layer. That means you will see this one will be the, this one is shear surface. Understood? This one is shear surface. This is the interface between Stern layer and diffuse layer. Shear surface. Now, when we are applying coagulant, then it gets dissociated into cations and anions. What I have shown you, R plus and R minus. These anions, R minus, will destabilize the boundary layer and make the colloidal particle free. We already discussed. This free colloidal particle will attach with the cations and they will form a small size flock. The whole process of destabilization and forming small size flock is called as coagulation or chemical conditioning. The whole process of destabilization and formation of small size flock is called as coagulation or chemical conditioning. The whole process of destabilization and formation of small size flock is called as coagulation or chemical conditioning. After coagulation, there will be flocculation or physical conditioning. This flocculation is called as physical conditioning. In this process, the Brownian motion between the small flock will be enhanced by mixing process. The Brownian motion between the small flock will be enhanced by mixing. Due to the increase in Brownian motion, small flock will collide with each other and two or more than two small flock will attach with each other and they will form bigger size flock. Due to the increase in Brownian motion, we have already discussed that due to the, see, this is suppose your increase in Brownian motion. Brownian motion means Lenz's motion, abrupt motion. Every particles are doing like this. Increase in Brownian motion, two or more than two small flock will attach with each other and they will form bigger size flock. They will form bigger size flock. This bigger size flock will be treated as single particle. This bigger size flock will be treated as single particle and they will get settled down according to their increase in specific gravity. This bigger size flock will be treated as single particle and they will get settled down according to their increase in specific gravity, because now two or more than two small size flocks we will not get. So these all the flocks are attached with each other. We will consider now it will be a bigger size mass, a single mass. So more time you will give, the size of the flock will increase. More time will you will give, the size of the flock will increase. The size of the flock will increase means eventually this flock will be the thing which will give you proper settlement. Higher the mass, higher chance of getting sedimentation. The higher the mass, specific gravity will increase. So, the sedimentation observed in this process is called as type 2 settling process or flocculent settling. This is called as type 2 settling process or flocculent settling process. Type 2 settling or flocculent settling process. Now, what is type 2 settling process or flocculent settling process? Let's discuss about it. In type 1 settling process, what we have seen, in type 1 settling, which is concerned about the discrete particle, right? What is discrete particle? The particle which don't change their property with time. So eventually, when you are concerned about the discrete settling, suppose this is the sedimentation tank, when you are concerned about the discrete particle settling, this is the particle, so this is actually Vs, this is your Vh, so this is the path of getting settlement. Particle, particle, particle. Vh, settling velocity is always same because no changes in properties in the particle. That is type 1 settling, no changes in the property. Sorry. What is happening? Leave it. Now, what about the type 2 settling process? In type 2 settling process, suppose this is the particle right now. The part as time increases, the other small flocks will attach. The size of the particle will get increased. The size of the particle will keep on increasing. the size of the particle will keep on increasing. The size of the particle will keep on increasing here. No changes there. So eventually, suppose this is your sedimentation tank. So initially, this is the particle. Horizontal flow velocity is Vh. This is Vs. When time increases, particle size will increase. Vh, Vs dash. Again, it will increase. So different time, Vs double dash. Settling velocity of particle will change as size difference is occurring. Size difference is occurring. So this that is a type 1 discrete settling, and this is type 2, or also called as flocculent settling, because the flocculated particle will get settled down here. It's called as flocculent settling. Flocculent settling. So this is the type 2 settling process, what we are actually concerned about. Type 2 settling process, what we are actually concerned about here. So as per the discussion of the different types of settling process, that actually type 1 or discrete settling is observed in the plane sedimentation process. Type 2 or flocculent settling is observed in the process of this coagulation and flocculation. And type 3 and type 4 we will see in the wastewater engineering itself. Now, the mechanism of destabilization, just we need to know the name. There are three mechanisms by which the chemicals or coagulant will destabilize the colloidal particle. First one is the adsorption and charge, not absorption, it's adsorption and charge utilization. Second one is compression of electronic double layer. And third one is entrapment of particle, which is called also called as sweep coagulation. This is very, very important. This is the most happening process, this sweep coagulation. Then we are going for this common coagulant used. There are lot many chemicals are there which can be used as coagulant, but we will go with the two coagulants, their positivity and the negativity of this process. First one is alum. The most used and most commonly found in the market is alum as coagulant. Alum, obviously you have seen in your home. Alum is Al2SO4 This dot 18H2 is the crystalline water. These water molecules are present in alum for the crystallization process. Now, when you are applying alum as coagulant, it is following a chemical equation which is Al2SO4.18H2O plus 3 calcium bicarbonate. I am giving you a balanced equation. Remembering this equation is very, very, very important. Sometimes in GATE and in other examination also, you have to apply. We will see when we will solve the previous year questions. We will see that they are giving question where you need to apply this equation directly, and on the basis of this equation only you can able to solve this question, those questions. But those equation will not be provided. It's better to remember the balanced equation. So for alum it is Al2SO4 whole 3.18H2O plus 3 calcium bicarbonate. CaHCO3 whole 2 is giving you calcium sulfate, 3 calcium sulfate plus 2 aluminium hydroxide, 2 AlOH whole 3 plus 6 CO2 plus 18 H2O. Alum Al2SO4 whole 3 dot 18 H2O plus 3 calcium bicarbonate CaHCO3 whole 2 is giving you calcium sulfate, AlOH whole 3 aluminium hydroxide, 6 CO2, carbon dioxide and water. Now disadvantages of using alum. When you are using alum, there will be certain disadvantages. What are those disadvantages? Try to understand from the equation itself. From the equation itself, because on the basis of these disadvantages, we will actually going to apply the next coagulant in water. Disadvantages of using alum. So I have written here, first of all, calcium sulfate. If you see, you are applying alum, it is providing you. See, I am writing calcium doesn't mean that only calcium is reacting with alum. It can be magnesium also. Then the equation will change where like it will be magnesium sulfate. It produces permanent hardness in water. Calcium sulfate, calcium chloride, non-carbonate hardness. Non-carbonate hardness means the apart from carbonates and bicarbonates. We have already discussed this. And this non-carbonate hardness, to remove this non-carbonate hardness, simple boiling process will not work. Simple boiling process will not work. What we have to do? You have to do the ion exchange method. So on the basis of this concept, the overall cost of the system is getting increased. Okay. So to produce permanent hardness in water, it produces. To remove this permanent hardness, we have to go for certain chemical treatments. Clear? That is the first disadvantages. Second one, alum is effective. See, alum is effective when they are reacting with the bicarbonate salts, HCO3 minus. And we have discussed in the quality of water chapter in the alkalinity, that is bicarbonate salts are predominant in the pH range. What? 4.2 to 8.3. So if you want to use alum effectively, it will be a pH dependent process. As it is a pH dependent process, that will be a disadvantage of this particular technique or process. ठीक है? तो और एक तीसरा चीज क्या है? The evolving of carbon dioxide gas. Evolving of carbon dioxide gas, though this negativity can be dealt with easily by a gas releasing pipeline. So alum is effective when it reacting with bicarbonate alkalinity. The bicarbonate alkalinity is predominant in the pH range 4.2 to 8.3. And it means the using of alum is completely a pH dependent process. Is completely a pH dependent process. And the most effective pH is 6.5 to 7 generally. On the basis of these negativities, we are going to use the second coagulant, that is copperas. Copperas is ferrous sulfate salt, iron salt. Copperas is the commercial name. There is no copper in copperas. FeSO4.7H2O. FeSO4.7H2O is the copperas. And it is used always with calcium oxide. कोई कोई बंदे रहते हैं अकेले नहीं रहते हैं इधर. कॉपरस वैसे ही बंदे हैं, इसका सब कुछ पॉजिटिविटी है, लेकिन भैया ये अकेले नहीं जाएगा सिस्टम में. Always needed somebody that is calcium oxide. Calcium oxide is the accompanying part of copperas. Now there will be two cases. When suppose you are applying lime in the water, calcium oxide in the water before copperas, or first you are applying copperas and then lime? Let's see what will happen in which case. Case 1, when lime added first, calcium oxide added first. When you are applying lime first, then it will form calcium hydroxide. Calcium hydroxide. Calcium oxide plus H2O, it's forming calcium hydroxide. And FeSO4.7H2O reacting with calcium hydroxide, it is forming calcium sulfate, ferrous hydroxide and water. The point is, अगर हम previous वाले part देखते हैं, this alum वाले में भी calcium sulfate या permanent hardness आ रहा था और pH का problem था. तो इधर देखिए कॉपर हाइड्रोक्साइड आयन के साथ भी रिएक्ट कर रहा है, मतलब हायर पीएच वैल्यू भी अगर होगा तो कोई दिक्कत नहीं. तो दो मेजर नेगेटिविटी था, जिसमें से एक नेगेटिविटी को तो आप डील कर लिए, लेकिन दूसरा वाला जहां पे परमानेंट हार्डनेस हो रहा था उसको आप डील नहीं कर पाए. उसके लिए आता है सेकंड केस, व्हेन लाइम इज एडेड लेटर. तो फर्स्ट यू आर अप्लाइंग कॉपरस रिएक्टिंग विद कैल्शियम कार्बोनेट, गिविंग कैल्शियम फेरस बाइकार्बोनेट, calcium sulfate and 7H2O. Then you are applying calcium oxide in water, forming calcium hydroxide. Now this ferrous bicarbonate will react with calcium hydroxide and will give you finally calcium carbonate and ferrous hydroxide. So calcium carbonate is actually क्या है? It is nothing but the temporary hardness. Carbonates of calcium, ये temporary hardness है, मतलब you will be able to remove this hardness easily from water by simple boiling process. By simple boiling process, you will be able to remove this hardness from water. Calcium carbonate. And there is ferrous hydroxide. Now, as ferrous hydroxide is unstable, it will react with oxygen, it will get oxidized, and it will form a precipitate, flock precipitate of ferric hydroxide. Ferric hydroxide. So, two things was there. दो नेगेटिविटी था आपका, क्या क्या इनको इन एलम में. एक था पीएच का कहानी और एक था आपका परमानेंट हार्डनेस वाला कहानी. पीएच का कहानी तो हम देख रहे हैं कि ये कार्बोनेट के साथ भी जा रहा है और ओएच के साथ भी जा रहा है, मतलब हायर पीएच कुछ भी हो जाएगा. एंड इट्स बाइकार्बोनेट सॉल्ट्स आर आल्सो रिएक्टिव, so the pH range will not be a matter for copperers. First point. Secondly क्या दिक्कतें हैं? दिक्कतें था आपका परमानेंट हार्डनेस वाला, वो पहला केस में तो नहीं डील हो रहा था, लेकिन सेकंड केस में फाइनल प्रोडक्ट में क्या आ रहा है आपका? कैल्शियम कार्बोनेट. देन इट इज आल्सो डेल्ट विद दैट. नाउ आप पूछेंगे कि भाई सर ये सिर्फ और सिर्फ अच्छा है, कुछ अलग नहीं है? नेगेटिविटी तो रहता है हर प्रोसेस का, इसका भी नेगेटिविटी है. क्या है नेगेटिविटी? जब हम आयरन देखे थे, कलर पढ़े थे, हम लोग बोले थे कि आयरन, मैंगनीज, कॉपर, these are the color causing ions, so it is not useful. It is not useful for colored water. जिस पानी में ऑलरेडी कलर है उसके लिए आयरन सॉल्ट इज नॉट यूजफुल, एंड आयरन सॉल्ट ज्यादा यूज करना भी सही नहीं है. तो क्या करेंगे कलर्ड वाटर के लिए? फॉर कलर्ड वाटर we need to use chlorinated phosphorus. मतलब phosphorus तो रहेगा ही, साथ क्लोरीन भी जाएगा. क्यों? Because chlorine is having some bleaching property. It will remove the color from water. Chlorine is having some bleaching property. It will remove the color from water. Okay. Now, बात यह है कि कोआगुलेंट डालेंगे और उस कोआगुलेंट से आपको मिलेगा फ्लॉक, छोटा छोटा जो फ्लॉक मिलेगा, उस छोटा छोटा फ्लॉक को अगर आप ब्राउनिंग मोशन से इंक्रीज करते हुए आपको बड़ा फ्लॉक मिलेगा। तो दैट इज अ प्रोसेस। अब बात है कि कितना कोआगुलेंट डालेंगे, जैसा मर्जी वैसा, बहुत ज्यादा डाल दिए वैसे नहीं है। तो देयर इज सम फिक्सिंग ऑफ ऑप्टिमम डोज ऑफ कोआगुलेंट, व्हाई इट इज रिक्वायर्ड। क्यों आप आपके मर्जी के हिसाब से कोआगुलेंट नहीं डाल सकते हो? ट्राई टू अंडरस्टैंड द थिंग, व्हाई दिस ऑप्टिमम डोज फिक्सिंग इज रिक्वायर्ड। देखिए, जब आप कोआगुलेंट डाल रहे हो पानी में, तो it is getting dissociated into ions. What type of ion? R plus and R minus. ये R plus वो channel वाला R plus नहीं है, I'm giving you as cations, okay? So R plus and R minus, these are the the ions you will see. Now ये R minus का काम क्या है? Helping in destabilization, right? Helping in destabilization. और ये R plus का काम क्या है? Attaching with colloidal particle and forming flock. Okay. अगर आप बहुत ज्यादा कोआगुलेंट डाल दिए तो क्या होगा? सिस्टम में R प्लस फ्री रह जाएगा इफ एक्सेस कोआगुलेंट। अगर R प्लस फ्री हो जाए, इट इज कॉल्ड एज चार्ज रिवर्सल। क्यों? आपके पास था नेगेटिवली चार्ज कोलॉइडल पार्टिकल, जिसको हटाने के लिए आपका ये R प्लस डालना बाहर से एक्चुअली में। तो नेगेटिवली चार्ज कोलॉइडल पार्टिकल को तो हटा दिया, लेकिन अभी क्वार्टर में पानी में पॉजिटिवली चार्ज पार्टिकल्स आ गया, इसको कहते हैं चार्ज रिवर्सल। अगर पानी में नेगेटिवली चार्ज पार्टिकल्स रहते हैं तो उसको हटाना मुमकिन है, लेकिन पानी में अगर पॉजिटिवली चार्ज पार्टिकल हो जाते हैं उसको हटाना मुमकिन नहीं है। क्यों? सोचिए, पानी में कुछ नेगेटिवली चार्ज पार्टिकल्स हैं, उसको हटाने के लिए आप क्या करेंगे? कैटायंस डालेंगे बाहर से कैटायंस लाइक सोडियम, कैल्शियम, मैग्नीशियम, इट इज अवेलेबल एज मेटल आयंस। लेकिन पॉजिटिवली चार्ज आयन हटाने के लिए अगर आपको बाहर से नेगेटिव चार्ज आयन अप्लाई करना है, जैसे क्लोराइड, सल्फेट, ये आयन के हिसाब से आयोनिक फॉर्म अवेलेबल नहीं है मार्केट में। किस फॉर्म में अवेलेबल है? अब वो सोडियम क्लोराइड फॉर्म में अवेलेबल है, कैल्शियम सल्फेट फॉर्म में अवेलेबल है। तब जैसे ही उसको डाल दोगे, सोचिए R प्लस है, इसको हटाने के लिए आप कैल्शियम सल्फेट डाल दिए, तो R तो बन जाएगा भैया, उसमें कोई दिक्कत नहीं है। लेकिन ये SO4 कहां से डिसोसिएट होकर जा रहा है? कैल्शियम से। डोजेस प्लॉट विल बी देयर। Now in turbidity versus dosage plot, turbidity in NTU, dosage in milligram per liter. If you plot, first of all, first you will see that if you increase the dose, turbidity value will be same, and after that it will keep on decreasing, because increasing the dose will result in removal of more and more colloidal particle. Removal of more and more colloidal particle is happening, and at a particular point, particular dose, turbidity value, after that it will again increase, because then again increase means turbidity increase means charge reversal has occurred. So the dose where the colloidal value is minimum, the turbidity value is minimum, the dose where the turbidity value is minimum is called as optimum dose. That particular dose where turbidity is minimum is called as optimum dose. So what we are taking, we are discussing in brief, that we are going for this jar test, where we will take several jars of 1 liter volume, and their mixing device will be connected for each and every jar. We'll put the colloidal particle coagulant doses, different doses in different every jars. Then first we'll go for rapid mixing, then we'll go for slow mixing, then we'll go for this stabilization condition, and finally we will take from each and every jar from the topmost part of the water, and we will measure the turbidity, and we'll plot the turbidity versus doses. We'll plot the turbidity versus doses of coagulant, and we will find out the minimum, the dose where the minimum turbidity is achieved. The dose where minimum turbidity is achieved will be called as the optimum dose of coagulant. The dose where minimum turbidity is achieved will be called as the optimum dose of coagulant. Now, now we are entering to the then, so all the concepts of coagulation is over now. Now we are entering to flocculation. Flocculation we have already seen, that is also called as physical conditioning. Flocculation is also called as physical conditioning. We have already discussed the chemical conditioning is coagulation, and physical conditioning is called as flocculation, because in this segment you are not going to use any kind of chemical from outside. What you will do, you will just enhance the mixing process, or enhance the Brownian motion by a mixing process, and due to the Brownian motion, increase in Brownian motion, small flocks will attach with each other and they will form bigger size flocks. This flocculation will be of two types: parakinetic flocculation, where mixing is done without any external forces. This is outdated generally. Then hydraulic rotor, given in this figure, is a parakinetic flocculation. Orthokinetic flocculation means where mixing is done by applying some external forces, that is generally done. In hydraulic rotor, you have seen that some arrangement is done, no external force is required, arrangement is done, just uh, decreasing the cross sectional area. See, you can find out that's decreasing the cross sectional area, so that water is passing through this, jet formation will be there, and just turbulence will be created, just making an arrangement where turbulence is created. Turbulence is created means eventually, obviously, turbulence mixing will be there. In mechanical rotor, rotation is happening. Now, design of Clary flocculator. Just a minute. Just 1 minute. Design a clariflocculator. But clariflocculator, from the term we have seen that clarifier means where the sedimentation will happen, and flocculator means clarifier plus flocculator. In clariflocculator, three things will happen: rapid mixing, flocculator unit, and settling time. Rapid mixing will done for detention time 1 to 3 minutes. Depth will be 1 to 1.5 meter. Volume will be defined by Q into dt, and surface area will be volume by depth. That is clariflocculator. Apart from this, there will be an important concept of velocity gradient. In this rapid mixing and flocculator unit, an important concept will be velocity gradient. What is velocity gradient? Generally defined by capital G. Don't mix the concept of capital G of specific gravity with velocity gradient. It's different. This definition is change in velocity with unit distance normal to cross section. Try to understand in details. So change in velocity. What is velocity? V by L. So velocity is meter per second. L is meter. Eventually the dimension of G will be time inverse. Okay. So what is happening? Suppose this is your tank and you are mixing. If you understand that when you are mixing something in the central segment of the tank, there will be turbulence created. और if you have done, अगर आप देखे होंगे आप बचपन में अगर आप कपड़े वपड़े धोने के टाइम पे एक बाल्टी पानी में कभी जो वॉशिंग पाउडर लेने के बाद जो आप हाथ से मिक्सिंग करते थे, what will happen? In the central part there will be turbulence created. So if you are mixing it, the central segment is having certain turbulence, and if you keep on moving towards the periphery, you will observe a reduction in turbulence, and in the periphery almost the turbulence will be negligible. Suppose here v is the velocity, here velocity will be 0, and this is the length L. Just I'm assuming. So what is G? The change in velocity per unit distance. So change in velocity, initial velocity, final velocity by unit distance, normal to a cross section. So obviously cross section area is this. Normal means the perpendicular to the cross section. It's happening like this. So if it is the tank, this is your cross sectional area. So obviously it is happening normal to a cross sectional area. Clear? So two cases, let it be. Case one, where mixing is happening, form mixing, V1 is 0. So G1 is V1 minus 0 by L, and same length if another cases where very slow mixing is happening. Like previously we were doing this, now we are doing this. So here suppose velocity is V2, that is 0. So where G2 will be equal to V2 minus 0 by L, same length. So as V1 greater than V2 will be G1 greater than V2. So when V1 greater than V2, V1 is, this is happening. Rapid means form mixing, and would be quite a slow mixing. So G signifies what? G signifies what? Degree of mixing. कितना ज्यादा mixing होगा will be defined by G itself. G value. So degree of mixing is directly proportional to the velocity gradient value. Degree of mixing is directly proportional to the velocity gradient value, where mathematically G is defined as under root P by mu V. Mathematically, G is defined by under root P by mu V, where P is the power applied in watt, P is the power applied in watt, and mu is the coefficient of dynamic viscosity, and V is the volume of tank in meter cube. P is the power applied in watt, mu is the coefficient of dynamic viscosity in Newton second per meter square, or Pascal second, or kg per meter second, whatever it may be. Tank in meter cube. G equals to under root P by mu V. And G will be in second inverse. G will be in second inverse. G will be in second inverse. Okay. Now, as G is having an unit of time inverse, so if you multiply a parameter which is having a unit of time, then that will give you a dimensionless number. If G is combined with detention time, then the product will be a dimensionless number, but detention time is TD, where GD is a dimensionless number. So what is G? G is under root P by mu V. What is TD? V by Q. So GTD is equals to, if you convert it, P V square by V, entering V here, it will be under root P V by mu by Q. What is Q? It's flow rate. And this whole ratio is nothing but a dimensionless number. So the denominator and the numerator is having same unit. So if the bottom part is Q, is flow rate, then above part will be also a flow rate. So under root PV by mu is called as power induced flow rate. Is called as power induced flow rate. Power induced flow rate. Okay. Now the value of GTD will be always constant for a given flow. The size and number density of flock will be defined by the value of GTD. जितना टाइम दोगे आप क्या होगा, साइज बड़ा होगा. So if GTD is constant, if you are increasing the giving higher TD, obviously it will be give lower G value. साइज बड़ा होंगे मतलब जितना टाइम दोगे उतना more and more flocks will attach with each other and they will form a bigger size flock. And lighter number density. Number density means, suppose previously, if in your process there will be lighter number density, that means अगर जितना टाइम दोगे तो उतना ज्यादा कम नंबर रहेंगे, साइज बड़ा होंगे लेकिन नंबर कम रहेंगे फ्लॉक का सिस्टम में. So if you increase the G or reduction in TD value, smaller flock and tensor number density will be there. But generally the GTD value will vary bigger and higher number density flock, for which we need to use tapered flocculation technique. What is tapered flocculation technique? Tapered flocculation technique में क्या होगा कि G value will keep on decreasing from inlet to outlet, and TD value will keep on increasing from inlet to outlet. Eventually GTD value will be always constant. From the figure itself, you can understand what is happening with the tapered flocculation technique. Now flocculator. Detention time will be in between 20 to 40 minutes. The volume will be L into B into H will be defined by Q into dt. But depth will be in between 2 to 4 meter. Surface area is volume by depth. The sedimentation tank is employed to settle down the flock produced, follows type 2 settling process. We have already discussed in details. In type 2 settling process, we will deal with the flocculent particle. Will keep on changing their mass and size. Flocculent particle which will keep on changing their mass and size. That is there. We've seen VS1 VH time increases, VS2 VH, because VS1 will not be equals to VS2 because size differs. Well, Vs is the settling velocity of particle, will keep on changing. Design parameter generally will happen in the SOR, surface overflow rate, 20 to 30 meter cube per day per meter square, and detention time 2 to 4 hours will be defined. Now, okay. Now the different factors affecting coagulation process: its turbidity, alkalinity, dosage of coagulant, turbidity is concentration of colloidal particle, type of coagulant used, and obviously the pH value. Whereas if turbidity is high, alkalinity is low, doses will be small. If turbidity and alkalinity both are higher, large doses will be required. And if turbidity and alkalinity both are low, then it will be difficult to coagulant. If turbidity lower but alkalinity is higher, medium doses will be required. Now, though I have told that if turbidity and alkalinity is low, then difficult to coagulate. But in this case also we can coagulate by two ways. First, we can add bentonite clay, which will increase the turbidity, and then calcium oxide, which will increase the alkalinity. By this process, we can coagulate the low turbid and low alkaline water also. That is the theoretical concepts of coagulation and flocculation. Let's recap the part. We have discussed what is happening: electronic double layer stability, stun layer, diffuse layer, zeta potential, xi, destabilization process, coagulant used, unit process, applying coagulate, dissociation in ions. Then flocculation, increasing Brownian motion. Due to the increase in Brownian motion, small flocks are attaching with each other and forming bigger size flocks. And then finally sedimentation when they attain enough size and mass. Then mechanism of destabilization. Then common coagulant used, alum. The disadvantages of alum: using alum, permanent hardness, pH dependency. Then copper as coagulant, two cases: added with calcium oxide, then before calcium oxide, then copperus, then first calcium oxide, then first copperus, then calcium oxide. Then we are going for the fixing of the optimum dose of coagulant. Why you need to fix the optimum dose we have discussed. Then jar test and the result of jar test. Then flocculation, parakinetic, orthokinetic flocculation. Design of clariflocculator, velocity gradient. What is velocity gradient? How it is important? What is the significance of velocity gradient? What is the mathematical equation? We have already discussed. Then GTD, significance of GTD, power induced flow rates and all, density and size of the flock and number density, tapered flocculation, flocculator, sedimentation tank, type 2 sedimentation, design parameter of sedimentation tank, then factors affecting coagulation and the doses along with the factors, and a note. That is all about the coagulation flocculation. We have completed the discussion of two units. One is plain sedimentation, another one is coagulation and flocculation. We'll discuss later on for filtration, disinfection, and groundwater treatment. So, Unacademy Combat is once again coming on 29th of December, 6 p.m. Enroll for free. Register now to unlock. Use the code CRACKGET. Exciting prizes are there. Live video solution will be provided. Questionnaire sets by the topmost educators. You will get 3-month subscription for Get an EAC or equivalent Amazon voucher and 500 Amazon voucher for rank 4 to 50. Unacademy Combat once again coming. Buckle your seat belt. Go for this. And for civil engineering students, 2022 GATE aspirants, a great news, New Year bonanza, New Year gift to you. 28th December, 11:15 a.m. Unacademy is launching Civil Batch A for in English and in Hindi. Don't be late. Better to start early. Subscribe this. During subscription, don't forget to use the code today. SEN10. SEN10 is the code. SEN10, my code. Use this. You'll get direct 10% discount. If you don't have the Unacademy Learning app, put there the Unacademy Learning app. Install it. During installation, put Get an EAC. Go for plus courses and go for the subscription. And during subscription, don't forget to apply SEN10. This is the code. So this is once again Civil Batch A, 28th December. Save the date, 28th December. Evolve for Get 2022, 11:15 a.m. Thank you for this session. See you in the next class with filtration process. Thanks a lot.